So you turned your attention to Venus. What were you looking for and why?
So this was a bit of a crazy idea. I got asked to look at what a future space telescope could do, looking for molecules around the solar system. And being a bit impatient, I was like, "Oh, what have we found already?" And like, these molecules like phosphine and ammonia, and I'm like, "Oh, phosphine, what on earth is that?" And it turned up in some studies of the Earth. It's produced by microbes in places where there's no oxygen. I thought, that's really neat. Wait, Venus is supposed to be a place where there's no oxygen in the clouds, but there might be some kind of life. I wonder if we could use a telescope we already have. And it turned out we didn't need the space telescope. Something we already had would work. Turn it on Venus and just look for this tiny missing bit of light in the spectrum. So that's what we did. We were actually really grateful. One of the telescopes, the James Clerk Maxwell telescope in Hawaii, was like, we don't mind having people having crazy ideas, have a few hours, we'll try it out for you.
So tell me a bit more about phosphine then. So what is phosphine? How is it made usually? And why is it seen as a potential biomarker?
So it's a very weird molecule that's not made very often on Earth. So it's one phosphorus atom with 3 hydrogen atoms attached. It's kind of like a slightly heavier version of ammonia, which we're more familiar with in daily life, which is like a nitrogen atom and 3 hydrogen atoms. We're not really sure why it's made by microbes, because Earth doesn't have a lot of free hydrogen. But some thought that these microbes on Earth might maybe make it easier as like a defense mechanism, because it's really toxic, mostly to larger life forms. So they could be using it in a way to like beat their enemies or something. So most of the studies on Earth are actually about its toxicity, to make sure it like doesn't escape from a sewage plant and kill people or something like that. But it does mean, because it's very rare on Earth, it's kind of a sign of where there are living things on Earth. So that's why we thought it might work for Venus. And because it's not made in hydrogen-poor places like the Earth and Venus, it's not made like in huge amounts by other processes. That's what makes it maybe a signal to there being life. Not definitely, but something that's worth looking for.
And what were you expecting? Like, were you thinking, oh, I think we really might see something here? Or beforehand, what was your expectation for the
I was really
result?
excited by the idea of being the first person to try this. And I was totally thinking, we'll just get one of these flat lines with a bit of chaotic wiggling in it. It can't possibly be that easy. So we'll get something that will be kind of a limit, interesting to a few other scientists, to say we can rule out like the clouds or wall-to-wall microbes was kind of the idea. And then we found something. I was like, oh, did not expect success.
So can you remember when you first saw that result come in?
Yeah, we'd been fiddling around with the data for ages and it didn't look super promising. And we had 140 spectra, and I'm not very good at like writing computer code. So it took me like more than a year to write something that would treat each of those spectrum separately and like clean it up and then add them all back together at the end, at which point we'd almost forgotten about the project, but I had a bit of free time, so I tried it, and then it sort of jumped out and I was like, oh no, what happened?
Did you have to do a lot of checking, or like trying to repeat that result, or like, that's quite a big deal if you've got something suggesting that there might potentially be life on Venus.
It was a very big deal, when I'd recovered from the shock and like had something to eat. I contacted my colleagues the next day and said, like, really looks like what we've got something, what should we do? And they were kind of like stunned as well. But this was about a year and a half after we'd tried it the first time, and Venus was kind of coming back around the sun with respect to the Earth in the same position again. So we asked the very nice people at the ALMA network of telescopes down in Chile if we could jump on Sky with them. And they were really kind, because that kind of involves a project that like supersedes all other regular projects that they're doing, like really important other science. But they let us do it for another hour and a half, I think. And the signal came back in that data. So we were like, oh, yes, this is really a thing.